Hey everyone, and welcome. Today, we are pulling back the curtain on one of the biggest headaches in modern software, really understanding what's happening deep inside our applications. We're going to dive into AWS Application Signals and see how it's changing the game.
So let me just ask you this. Have you ever felt like your application is a total black box? You know it's out there running, users are definitely clicking around, but the second something goes wrong, you're just kind of left guessing, trying to peer into the darkness.
And it's not really your fault. The way we build software these days, with all the microservices, containers, and serverless functions, it gives us all this incredible power, but man, does it create some complexity. Every single piece is a potential blind spot, making it almost impossible to see the whole picture. So yeah, that really gets us to our first big topic, this inherent complexity in our systems and the super frustrating blind spots they create. This is the core problem that keeps developers and ops teams up at night, for sure.
I mean, this is the reality for so many of us, right? An alert goes off, and bam, you're thrown into this troubleshooting maze asking all these frantic questions. Which of the 50 services is the actual problem? Was it that deployment we just pushed 10 minutes ago? And the big one, are customers hitting this right now? It's just a super high-stress, low-visibility situation.
But what if you could just flip a switch and get an automatic blueprint of your entire application? Well, that's exactly the promise we're going to explore right now. Let's take a look at how this totally new way of seeing your system actually works.
And this is it, AWS Application Signals. Now, at its core, it's an APM. That's Application Performance Monitoring feature inside of CloudWatch. But the real magic, the part you need to hear, is that word automatically. It finds your services, it maps out how they all talk to each other, and it tracks their performance, all without you having to go in and manually change a bunch of code.
Just look at this contrast here. The old way was, let's be honest, a real pain. You had to manually instrument your code, kind of guess which services depended on which, and then try to stitch together data from like 5 different tools. The new way is all about automation. We're talking live dependency maps, one single unified view, and it even connects performance problems directly back to recent deployments. It's a huge leap forward.
And this is such a brilliant way to think about it. Imagine Application Signals as a live GPS for all your application's traffic. It doesn't just show you the map, it shows you the real-time flow of requests, where the traffic jams are, and points you right to the accident the moment it happens. It gives you a clear path to the problem.
So how does it pull off all this automatic visibility? Well, Application Signals is really built on 3 key pillars that all work together: monitoring your services against goals you define, proactively testing the user experience, and then observing what your real users are actually seeing.
Okay, first up, Service Level Objectives, or SLOs. This is about moving past just waiting for an alert when something is on fire. Instead, you get proactive. You define what good actually looks like for your service, like, say, 99.5% availability, and then you're constantly measuring how you're doing against that goal. It's a total shift from reactive firefighting to proactively protecting your reliability.
And that goal creates something really powerful called an error budget. So if your target is 99.5% success, your error budget is that leftover 0.5%. That's your allowance for acceptable errors or downtime over a set period. It's an awesome concept because it tells you exactly how much risk you can take before you start breaking your promise to your customers.
The second pillar builds on this with proactive testing, using something called synthetic canaries. Just think of these as little robot users that you deploy. They're tirelessly running through your most critical workflows, like logging in or adding an item to the cart, 24/7. They are your early warning system, designed to find issues long before a real person ever does.
And the best part about these canaries is how simple they are. You just create a test, a lot of times from a template that's already built for you, schedule it to run around the clock, and you get an alert the instant something fails. It's proactive monitoring made really, really practical. And finally, the third pillar is Real User Monitoring, or RUM. Now, while canaries simulate users, RUM tells you what your actual users are experiencing. It captures performance data right from their web browsers, showing you things like page load times, any client-side errors, and the actual paths they're taking through your app. This is your ground truth.
Okay, so this all sounds amazing, right? But how hard is it to set up? Because that's usually the biggest hurdle with any of these kinds of tools. Well, the whole goal here is simplicity. So let's talk about actually flipping the switch.
From a high level, the process is pretty straightforward.
First, you enable the integration for whatever your environment is, Kubernetes, Lambda, you name it. Second, you give your service a name using a simple tag so it can be identified, and then you just deploy. Application Signals literally takes over from there, discovering and mapping everything for you.
And here is a perfect example of what that tagging looks like. See? It's not some complicated piece of code. It's a simple environment variable based on the OpenTelemetry standard. All we're doing right here is telling the system, hey, anything running here, it's part of the payment service. That one little line gives Application Signals all the context it needs to start building out its map.
All right, let's bring it all home. We've gone from the problem of complexity to a solution that gives us this amazing automated visibility. The final piece of the puzzle is understanding the real-world impact, how we go from just having raw data to having truly actionable insights.
So why does all this matter? It matters because you're trading guesswork for instant understanding of your entire architecture. You are shifting from being reactive to being proactive, catching problems before they become outages. It means you can solve problems in minutes, not hours, because the system connects all the dots for you. And maybe most importantly, you can finally draw a straight line from your technical performance to the actual business impact.
And that really leaves us with one final thought. Just imagine all the time and energy your team spends on that frantic troubleshooting, on all the guesswork, on just trying to see what is going on. What could you build? What could you innovate? What could you create if you never had to fly blind again?
Thanks for tuning in.